students, this is day 2 of the chapter Energy, and specific objective for today's class is different forms of energy. In previous class we have discussed about force, work, energy and units of work and energy. And today we will learn about different forms of energy, that is mechanical energy. Under this we will learn about kinetic and potential energy. Then sound energy, chemical energy, electromagnetic energy, electrical energy, then nuclear energy and solar energy. So let's get started. First of all, mechanical energy. Students, this is the energy possessed by an object due to its position or motion. For example, a running car, moving gears, rolling bicycle, etc. In fact, all the moving parts of machines, they possess mechanical energy. And this energy is a sum of kinetic energy and potential energy. Now, what are kinetic and potential energies? Let us understand. Students, kinetic energy is the energy possessed by an object due to its motion. For example, a moving car possesses kinetic energy and running water also possesses kinetic energy because they are in motion. Students, how can we calculate kinetic energy possessed by an object? There is a formula. 1 by 2 mv square. Now what is m? M is mass of the object, of the moving object, whereas v is the velocity of the moving object. So we can say that kinetic energy depends on mass and velocity of the object. If the moving object has more mass, its kinetic energy will be more. And if it is moving with more velocity, then it possesses more kinetic energy. Next is potential energy. Students, the energy possessed by an object due to its position or configuration is called potential energy. Configuration means its shape or size. For example, a book lying on table, water stored in dams, etc. In fact, any object that is placed at some height from the ground possesses potential energy, as shown here. In this figure, this stone is at some height from the ground, so it possesses potential energy. Students, in order to calculate potential energy, we have this formula mgh, where m is mass, g is acceleration due to gravity, and h is height of the object from the ground. So we can say that potential energy depends upon mass of the object, acceleration due to gravity and height of the object from the ground. More the mass of the object, more will be its potential energy. And more the height of the object from the ground, more will be the potential energy possessed by the object. And acceleration due to gravity, that is value of g is fixed, that is 9.8 meter per second square. Let's read from the book now. Mechanical energy. It is a moving energy. It is the form that we most see around us. All moving objects produce mechanical energy. As I told you, the movements within machines is also mechanical energy. For example, people are rolling bicycle, moving gears and running cars. All these possess mechanical energy. Why? Because they are in motion. It is of two types, kinetic and potential energy. What is kinetic energy? It is defined as energy possessed by a moving body by virtue of its motion. For example, any moving body possesses kinetic energy. And what is potential energy? It is the energy possessed by a body by virtue of its position or configuration. For example, a body at a certain height from earth possesses potential energy. More the height of the object from the ground, more will be the potential energy, right? And more the mass of the object, more will be the potential energy. Next form of energy is sound energy. We all are familiar with sound energy. Sound energy is defined as a form of energy that gives us a sensation of hearing. Students, sound is produced only by a vibrating object, right? For example, when you put your hand on a speaker while playing music, you can feel the vibrations, right? Also, when you strike a tuning fork, as shown in figure, gently on a rubber pad, it starts vibrating. When these vibrations reach our eardrums begin to vibrate and we hear sound, right? Let's read from the book Sound Energy. It is produced when an object is made to vibrate. Sound energy travels out as waves in all directions. Sound needs a medium to travel through, such as air, water, wood, and even metal. If there is no medium, no sound can be heard. If there is no medium, sound cannot travel, so it can't be heard. For example, in space, there is no medium, no air, and astronauts, they carry a device to hear each other's sound because sound cannot travel in space. Examples are voices, whistles, horns, and musical instruments. Next type of energy is chemical energy. Students, it is defined as a form of energy that is stored in the bonds of chemical compounds. It is released during chemical reactions, usually in the form of heat. For example, when we strike a matchstick, the chemical energy is released in the form of heat. It is stored in many substances like food and substances like coal, kerosene oil, wood, etc. Mostly all the fuels, they contain chemical energy, and when we burn the fuel, that chemical energy is released in the form of heat and light. Let's read from the book for better understanding chemical energy. It is really a form of potential energy and is the energy stored in food, gasoline, or chemical combinations. Examples: striking a matchstick, combining vinegar and baking soda to form carbon dioxide gas. Breaking light sticks releases chemical energy. When vinegar and baking soda they are combined, chemical reactions take place between them and chemical energy is released. Next is electromagnetic energy. Electromagnetic energy is defined as the energy that is possessed by electromagnetic waves. Now, what are electromagnetic waves or radiations? Students, electromagnetic waves or radiations are the waves that have both electric field and magnetic field components. We will learn about electromagnetic waves or radiations in detail in 10th standard. Electromagnetic radiations consist of heat and light energy. Let's read from book. Electromagnetic energy, it is a combination of heat and light energy. As I told you, light energy like sound energy travels out in all directions in waves. Which waves? Electromagnetic waves. Examples: a light bulb, the glowing coils on a toaster, the sun, and even headlights on the cars. In fact, heat and light energy, we can say, they travel in the form of electromagnetic radiations. So they are basically electromagnetic energies, right? Next is electrical energy. Students, the energy produced by moving electrons is called electrical energy, and it is used in the form of electricity to rotate fans, drive trains, glow bulbs, run washing machines and water pumps, and many more. Let's read from the book. Electrical energy. Energy produced by electrons moving through a substance is known as electrical energy. We mostly see electric energy in batteries and from the outlets in our homes. Electrical energy lights our homes, runs motors, and makes our TV and radios work. In fact, it is used in all electrical appliances. For example, CD players, TVs, and video games, etc., and much more. Next type is nuclear energy. Students, the energy stored in the nucleus of an atom. Nucleus is the central part of an atom, and the energy stored in the nucleus of an atom is called nuclear energy. It is released in nuclear fission and nuclear fusion reactions. Students, let us understand what are nuclear fission and nuclear fusion reactions. Nuclear fission means breaking of a large nucleus into small nuclei, as shown here. And nuclear fusion means combination of two small nuclei to form a bigger nucleus, and in both the processes tremendous amount of energy is released, and that energy is called nuclear energy, right? Nuclear fission reaction is used in atom bombs, whereas nuclear fusion, it takes place in sun, due to which energy of sun is produced. We will learn about fission and fusion in detail in higher classes. Let's discuss few uses of nuclear energy. Students, nuclear energy is used for generating electricity in nuclear power plants, and it is used for making atom and hydrogen bombs, and it is used for treating cancer and other diseases also. Let's read from the book for better understanding. Nuclear energy, it is produced when you split atoms. A tremendous amount of energy is released when this happens. And this process of splitting atoms, this is called nuclear fission. In both nuclear fission and fusion, tremendous amount of energy is released, and that energy is nuclear energy. For example, atom bombs, nuclear power plants where electricity is produced, nuclear submarines, and the sun. In sun, nuclear fusion reaction takes place and lot of energy is produced. Next is solar energy. We all know what is solar energy. It is a form of energy that is obtained from the sun. There are various uses of solar energy. It is used for heating. It is used for cooking food in solar cookers. It is used for drying, like drying clothes. And it is also used for producing electricity by using solar plates or solar panels. Let's read from the book for better understanding solar energy. It is the energy radiated by the sun. It has been used for thousands of years in many different ways by people all over the world, as well as its traditional human uses in heating, cooking, and drying. It is used today to make electricity also, where other power supplies are absent, by using solar panels, such as in remote places and in space. It is becoming cheaper to make electricity from solar energy, and solar energy is also a clean source of energy. It does not cause any type of pollution. In many situations, it is now competitive with energy from coal or oil. Energy produced from coal or oil, it causes pollution, whereas solar energy is clean source of energy. A solar cooker can be used for cooking food. Students, you must be able to answer all these questions. First is, explain different forms of energy by giving one example of each. What is mechanical energy? What are its different forms? Write down few uses of nuclear energy. And what do you mean by solar energy? Write down its few uses. Note down all these questions and revise properly. Thank you.